All right, where were we? This next one is another antiderivative problem where it looks kind of messy, but recall that when we have, same as before, when we have a monomial denominator, we can just divide through. A good first step on this, however, would be to distribute in the numerator. We've got x squared minus x minus 2, I think. Looks right. And we're dividing that by x to the 1/2. That's the same as the square root of x. And then we can subtract our exponents. We've got 2 minus 1/2 is 3/2. We've got 1 minus 1/2 is 1/2. We've got 0 minus 1/2 is negative 1/2. And then we're ready to do the inverse power rule. For each one of these, we add 1 to the 3/2 to get 5/2. We're dividing that by 5/2. We add 1 to the 1/2 to get 3/2. And we're dividing that by 3/2. And we add 1 to the negative 1/2 to get 1/2. We divide that by 1/2. Don't forget your plus c. That's your answer, but we're going to make it a little nicer looking. We are going to remember that we're dividing by fractions, which is the same as multiplying by reciprocals. So we've got 2/5 times x to the 5/2. We've got 2/3 times x to the 3/2. And we've got negative 4 times x to the 1/2 plus c. And again, we could probably get away with leaving the answer like this, but sometimes in our multiple choice questions we have to simplify this a bit more. I might try to factor out a GCF here of x to the 1/2, and that way we could have whole numbers for our exponents here. We've got 5 minus 1 is 4, so we have 4/2 or 2. We've got 3/2 minus 1/2 is 2/2 or 1, and then this x to the 1/2 was gone from the entire term. Just make sure you put that plus c outside of the parentheses. That's a fairly important thing to do, because we're not multiplying our constant by that times that x to the 1/2. So, at any rate, that is one form of your final answer. You could also find a common denominator there and combine terms, but I won't spend time doing that. So those are some examples of the inverse power rule. Other antiderivatives include the trig derivatives, but those are just things we have memorized. For example, we know that the sine of x is the answer to the derivative of the cosine of x. But wait a second, that's not quite right, because the derivative of the cosine of x is negative sine of x. So we're going to toss a negative out front here, and we'll remember our plus c. Same deal with the cosine of x. That's the answer to the derivative of the sine of x. And this time we don't put a negative there because we don't need one. Secant squared of x, well, that sounds like a complicated thing, but we remember that that was actually the answer to the derivative problem of the tangent of x. So that's just something we have memorized. Likewise, negative cotangent of x for negative cotangent of x for the cosecant squared of x. Again, check these by taking the derivative of your answer, and you should get your integrand. And we know that secant of x differentiates to secant of x times tangent of x. So the antiderivative of secant of x times tangent of x must be secant of x. And likewise, we've got our negative cosecant of x. Whoops. Negative cosecant of x plus c for that last one. So again, those are just ones we already had memorized, so just wanted to remind you of them. All right. Last bit we're going to do here in this section is initial values. So the idea here is that if we are given some information about the original function, then we don't have a plus c anymore. For example, if we have f prime of x equals 3x squared, we know that f of x is going to be the antiderivative of 3x squared dx, which we can do pretty easily. We're experts at that at this point. We know that that's going to be x cubed, but we have some sort of unknown constant. So this is what f of x equals. Okay, so f of x equals x cubed plus c. We don't know what c is, except they actually give us this initial value right here of f of 2 equals 0. So that tells us that f of 2, which is the same thing as, according to our answer over here, is 2 cubed plus c. That is equal to, well, they told us what it's equal to. It's equal to 0. So we've got 8 plus c equals 0, or c equals negative 8. So actually, we don't have a plus c in our answer. We know that f of x is equal to x cubed plus c, where c is a negative 8, so minus 8. So that function is it satisfies both that we have the derivative of 3x squared when we take the derivative, but also when we take f of 2, we get 0. So to finish this problem off, we're going to say, well, let's evaluate this when x equals negative 2. So we'll get negative 8 minus 8, or negative 16, is our final answer. This next problem works pretty much the same way, except we're given the second derivative. So the first step is to take the antiderivative of the second derivative to get the first derivative. So 5x, when you take the antiderivative of that, well, we've got our x to the first changes to x squared, and then our 5 has to be divided by our new exponent of 2, and we still have our constant of integration there. But we don't want that constant of integration. We're going to try to get rid of it, and we're going to use that initial value. We're told that f prime of 0 equals 5, but we also know that f prime of 0 equals 5 halves of 0 squared plus c. So if we set those two equal to each other, we can see pretty clearly that c equals 5. So that tells us that f prime of x equals 5 halves x squared plus c, which is 5. And if we know what f prime of x is, we should be able to take the antiderivative and find what f of x is. So we'll do that one more time. The x squared turns into an x cubed. We're going to divide this coefficient by 3, so we're going to get 5/6. The 5 anti-differentiates to 5x, and again, we still have a c. This is a different c from our last problem because this is a different function. So we'll do f prime, or we'll use our initial value of, nope, not f of 5, f of 0. That's a nice one, because we do 5/6 times 0 cubed plus 5 times 0 plus c, but we're told that that equals negative 5. So this c value is actually equal to negative 5. So we're almost done with this one. We'll just do, we know that f of x, in this case, equals 5/6 x cubed plus 5x plus c, where that c is negative 5. So we can just evaluate this. From here, it's just some arithmetic. And we end up with, well, whatever we end up with. This, I guess, is 625 over 6 plus 20. 25 minus 5. And then when we get a common denominator here, we'll get 625 plus 120 over 6, or 745 over 6 should be our final answer. All right, so we can see these problems show up in our motion problems as well. If we are told what the velocity of a function is, we can take the derivative of that to find the acceleration, but we can also take the antiderivative of that to find the position. So if we take the antiderivative of our velocity, we're going to get our position function. So I guess I'll call that p of t, p for position. The antiderivative of 4t dt is, well, we get t squared. We take our 4 divided by 2, we get 2. The minus 3 turns into minus 3t, and we still have that plus c. Our initial position is 14. Well, what does that mean? Well, initial position means that the position at the beginning, when t equals 0, is 14. So p of 0 equals 2 times 0 squared minus 3 times 0 plus c, which is equal to 14. But since these are all 0, we just have c equals 14. So our position function is now p of t equals 2t squared minus 3t plus our c value of 14. So now we can find our position at any time. And they ask us to find the position at time t equals 3. So we'll just replace our t value with 3 and evaluate. And we end up with, I guess that's 18 minus 9 plus 14, or 9 plus 14 is 23, which coincidentally is my favorite number.